So today we're going to be doing physics circular motion 101. All right, so the question says a car goes from It goes from 100 kilometers per hour right to 0. So our V1 would be equal to 100. Our V2 would be equal to 0. 0 does not have any magnitudes or values behind it like kilometers per hour because it is at 0. No matter what happens to it, it will always stay 0, so nothing will affect it. Our time, it says time is 5 seconds. During an accident, the Kleenex box in the back of the window gets launched forward. Draw an FBD for the box, calculate its acceleration. So our free body diagram. FBD. So we have two forces acting on it. So for our FBD, this will be our Kleenex. We're going to have our force normal. Our force normal, that is going to be equal to our force of gravity. And then we're going to have our force our FP, which will be when the car stops moving, the sudden jolt from the car will send the Kleenex flying. So those are the three forces acting on it. After that, we have to find our A value, because our A value is first, or that's all it tells us to find. So we already know that our FP is also going to be equal to our MA, and we also know that our Fn and Fg cancel out, so that would just be equal to 0. We have two velocities, so we're going to use the equation A is equal to delta V over delta T. After we have that, we already know that our delta V is going to be equal to V2, so our second velocity minus our first velocity, all over our time. So, and if we just sub in our values at A, so it's going to be 0 minus 100. In other words, because it's in kilometers per hour and we don't want it in kilometers per hour, we're going to have it divided by 3.6. So this will be, and then our bottom will just be our time at 0.25. At 0.25 seconds, we can plug this into our calculator, where our 100 divided by 3.6 is going to be equal to 2.7. So 0 minus 27.77 ... 8 all over our time, 0.25. We are going to get roughly 111.11 continuously going on for 1. So for our acceleration, our units will be meters per second. Don't forget the squared. And can't forget our direction. This will be negative, and our direction will be to the left. Since it is negative, our real direction would be 111.11 meters per second squared to the right. So in the end, when we have a negative acceleration, all it means is that we can switch our direction and it will be unnegative or not negative due to so let's say I have something accelerating this way, right? Acceleration is that way. And we have another force acting on it this way. This will be our force applied. So if I have a car accelerating this way, this direction, and I have a force applying it to the truck or the car in this direction, we are going to be deaccelerating, which our A is going to be in negative. So try pushing something that's moving towards you. It's going the opposite direction, or or it's going to be going the opposite direction, but the acceleration would be negative. Or it would just be going the other way, like that, instead of going negative like that. Just like that. So regardless from that, that is our first question. We have our answer, our acceleration at 111.11 meters per second squared going right. So we can either write it like this, or we can write it as 8, because it's the exact same thing. Our north, east, south, west, we can tell that this is the way it's going, therefore it's going to go east. All right, now to question 2. All right, so for our next question, we are given the mass. Our mass will be equal to 70 kilograms. A driver brakes at a constant rate of deceleration. So remember, we stated that deceleration, this will be equal to A negative, right? She stops from a speed of 80 kilometers per hour east in 4.2 seconds. So our time will be 4.2 seconds. 2 seconds. You don't forget to write your units. Always important to write your units. From a speed of 80 kilometers per hour. So our V1 is going to be equal to 80 kilometers per hour, and she stops. So stops, this right here will just signify that she's at rest, which is 0. So she stops from a speed. So V1 is going to be speed, and she stops from her V1, which will be 0. So V2 is going to be equal to 0. No direction, no magnitude, no nothing. So 80 kilometers east. So we see how she says they say east. We have to state that it's east as well. So this will come in handy for further into the question. And after that, after 4.2 seconds, the driver applies a force of 180 newtons horizontally from her arms onto the steering wheel. So our force applied, because we're applying a force, will be equal to 180 newtons onto the steering wheel, so horizontally. We can just draw it like this. We can just draw it like that, or we can actually write horizontally. So we can either have it like that or that. From her arms onto the steering wheel, determine the amount of force of the safety belt applies to the driver. So safety belt, other known as seat belt, right? So we have our seat belt. Matter of fact, let's draw a diagram so we can get a better idea of this. So we already know that we're gonna have a steering wheel. This is our steering. All right. This will be our steering wheel. Get a circle. We can make it at an angle. All right, whatever. So we have our steering wheel. We have our hands over here. Let's have 2 hands right here. And we have someone, let's have a stick figure person pushing onto the brakes, sitting down in his chair, whatever he's doing, right? So this force that he's applying right here is going to be 180 newtons. With that, we also have a seat belt that's coming around him and strapping right into the chair. So his chair, or whatever he's sitting on, that seat belt is the force that we need to find. We need to find the force that the seat belt is applying, which we can write as F of seat belt is equal to unknown. All right, so now for our time for our free body diagram, our FBD, which states all the forces acting on it, so we can figure out how to solve for our seatbelt. So we have our force normal, which is opposite to gravity. force normal, and we also have our force of gravity. These will be equal. So these two will be equal. We have our force of P, so the force that's being exerted, FP, FP, and we have two forces going backwards. And we always have to draw them accurate. So try to draw Fn and Fg equal. If they're equal, Fp is a stronger force, so it's going to be bigger than both of these. So this will be our force of the seat belt, or steering wheel, sorry. Force of the steering wheel. This will be force of the seat belt. And as we know, our Fnet equation, so our Fnet in the x direction, Fnet in the x direction is all we'll need, because our Fnet in the y will just be equal to Fn minus Fg. Therefore, if they're equal, they're going to be equal to 0. So our Fnet is going to be equal to our Fp, which is our greatest force, minus our F of the steering wheel, minus our Fsb. So we have both minuses there, or we can write as Fp minus bracket Fst plus Fsb. We can write it as that because this will just factor into this one, and it'll also factor into this one, making both of these negative, both of these equations equal. So our Fnet in this scenario will be set to 0. So we can just write 0 here. Right there, we can write 0. So, and if it's 0, so we can write our equation as our 0 is equal to Fp minus Fst plus Fsb. Right? And now to rearrange for our Fsb, we have to obviously factor in these two, this -1 in front that we don't see because we don't need to. And once we do that, we can take this, which would be a negative, and move it over to here. So we can do plus Fsb plus Fsb. So our force of our seat belt will be equal to our Fp minus our our force of the steering wheel, or force applied onto the steering wheel. So we know that we don't know what Fsb is equal to, but we know what Fp is equal to, which is going to be equal to ma of the car. So we have to find acceleration of the car. And our Fs, force of the seatbelt, would just be minus 180 newtons because it's all the way up here at 180 newtons. So we have to find our acceleration of the car. We have our delta V, which is going to be our V2 minus our V1. We have our time, so we can obviously find acceleration. Let's go over here. Acceleration is going to be equal to our delta V over delta T. So since there's no change in time, our delta T would just be 4.2, and our V would just be equal to 0 minus 100, no, just 80, my bad, 80 kilometers per hour, right, all over our 4.2. Therefore, our A is going to be equal to -80, but remember, since it's kilometers per hour, we have to divide it by 3.8 first. So divide by 3.6, sorry. So this will be our top bracket over our 4.2. For this, we will get -80 divided by 3.6 divided by 4.2. We will get A equal to -5.291 meters per second squared. And remember how I said that we're going east? So this will be east, in the east direction, this way. So since it's going that way, how can we write this in a positive format? I'll give you a couple seconds. You're right. We can write it in a positive format as changing this direction to going to the other way, or making this east turn into west, because that is the opposite of east. So we can do 5.291 meters per second squared at west. So once we make it west, it will no longer be a negative, and it will will just be positive west. So now since we found our acceleration, we can plug it back into our formula. We already know our mass, which is going to be 70. So our FSB will be equal to 70 times 5.29 minus 80. Now, when you're calculating these, you always want to keep your answer in the calculator, which my answer was 5.291005291. Right? So I want to keep that in my calculator, multiply that by -1 to get it out of the negative, which we did over here, and then multiply by 70, which will give us our 370.3, now minus 180, which will give us our force of our seatbelt at 190.37 newtons. Since we're using a force is always going to be measured in newtons over here, so we write newtons as an N. And we have to always state our direction, and since this is in that direct west direction, we can write west right behind it in brackets. Alright, so for question 3, this one says, calculate the apparent weight. So apparent weight is just mg, or we'll just mg. Let me write that better. Okay, it's not straightening out. mg. Calculate the apparent weight of a 60 kilogram person in an elevator that slows from 3 meters per second to rest. So we stated in the previous question that rest is going to be equal to 0. So our V1 is going to be equal to 3.0 meters per second. You don't have to write the 0. I just write it just because I think I'm smart. V2 is going to be equal to 0. So we already have our mass as well. Mass is going to be equal to 60 kg. And we have our time as in 2 seconds. I'll write my time over here to have space. Is equal to 2 seconds. The elevator is going up. So since we have our elevator's direction, this will go upwards until rest. So it'll be going up until it completely stops. So this will be 0, and this constant velocity will be 3 meters per second going upwards. So if you don't understand that, I can't help you. I'm kidding. Of course I can. I'm smart. So let's draw our FBD to start off with so we can understand what's going on in this problem. So our FBD diagram, free body diagram. So we're going to have our force normal and FP contradicting our force of gravity. So force normal, and we're also going to have our force of P, FP, and then our force of gravity is what's going to be pulling us down, so our FG. So we're going to make up positive and down negative. So our up is going to be represented as a positive value. Secondly, we have to write our F net equation. So our F net is going to be, or this will be in the y value because we have nothing in the x value. So the y and the x come from, so if you're in grade 12 physics, obviously you're going to know what your x and y values are. Your y value is going to be upon your y-axis, and your x value is going to be on your x-axis. This is the way your x-axis is going to go. This is the way your y-axis is going to go. So up and down, or up and vertical, or vertical and horizontal. So our F net in the y is going to go as our force of P plus our force, because we made up positive over here. So we're going to have this. We are going to have our FP over here plus our force normal over here, and we're going to minus our FG because this is the only value contradicting our force. Our force is going up. So minus our force of gravity. We already know that force of gravity, let's write it up here, force of gravity is going to be equal to since we have our mass and we already know what gravity is going to be equal to 9.8 meters per second. So let me box this in. We have our force normal, which is also going to be equal to, we actually don't know our force normal, but we can say it's going to be equal to mg as well because it's contradicting our force of gravity, but not in this case because we're trying to find our force normal, which is our apparent weight, which is going to be also equal to mg, right? So we also have our FP. We're going to set our F neti to 0, and we have to solve for a force normal. So to solve for a force normal, we have to move everything off to the other side and make sure that our Fn stays positive. So Fn will be equal to Fg minus Fp. So see how I moved this one all the way over to the other side? So we get positive Fg, and then we move this one all the way to the other side, and we get our negative Fp, which was stated over here, and over here. So after we have those values, we can solve for our n. Our Fn will be equal to mg minus our ma. And since we have two common values within these Fg and Fp, our Fn will be equal to m times gravity minus acceleration. So yeah, obviously if you took grade 11 math or grade 11 physics, we already know that we can factor out an m because they're equal. So we have our g, we have our m, we do not have our a. So what do you think we can do to find our a value? We have our delta v over here, we have our time, we have to find our acceleration. So what do you think we can do? Great, we can solve for acceleration. Acceleration will be equal to delta v over delta t. Since we only have one time, there's no change in time, our t is just going to be at 2. Now we have our 0 minus 3 divided by 2. And this just gives us, if you do simple quick math, it's going to be negative 1.5 meters per second. Hold up, let me write this better. Negative 1.5 meters per second squared upwards. Right? Since we are going up, this will be in an upwards direction, but remember, when we have a negative acceleration, it's going to be equal to the positive acceleration in the opposite direction. So ms squared, and this will be downwards. So after we found our a value, we can go over here and find our Fn. So our Fn is going to be 60 times 9.8 minus 1.5. Because if it was negative, it would be negative, and that would make a positive, and we don't want that, so it would be just this. So after that, we can find our values, our Fn, which is going to be equal to 498 newtons. This is just rounded, so obviously if it's below a 0.5 threshold, we're going to go round to the down. If it's above 0.5 and above, then we're going to round up. So you just round it to the nearest whole integer. And that's it. So that is how you do all 3 questions. Leave your questions in the comments. I'll answer them as soon as possible.